Good morning, sir. This is S.N. Mushkina Banu from CSE branch, C section, studying 2nd BTech, first semester. My topic for caa-2 assignment is transaction states and acid properties. The question is, apply the concepts of transaction states and acid properties to explain how the database system handles this situation to ensure consistency and recoverability. Coming to the content slides, what we are discussing today is Introduction to Transaction States, Transaction States Overview, Introduction to Acid Properties, Introduction to Consistency and Recoverability, Mechanisms for ensuring consistency, Strategies for recoverability. Introduction to Transaction States. In this slide, we are discussing about what is transaction and transaction states. Transactions are a sequence of operations performed as a single logical unit of work. Understanding transaction states is essential for maintaining the integrity of a database. Each transaction can be in one of several states throughout its lifestyles. As we all know, transactions are a sequence of operations performed as a single logical unit of work. Let us take a brief overview on transaction states. States of a transaction. There are 5 states of a transaction. They are active state, partially committed state, failed state, aborted state, and last is committed state. The main transaction states include active, partially committed, and committed. In these 5 states, we are discussing about 3 states which are main transaction states in a transaction states overview. Each state represents a different phase in the transaction's execution. The progression through these states is crucial for ensuring data consistency. Let us discuss about active state. The active state indicates a transaction that is currently executing. During this state, changes made by the transaction are not yet permanent. The transaction can be committed or aborted based on its success or failure. The second one is partially committed state. A transaction enters the partially committed state after its final operation is executed. At this point, changes are still not permanent as like active state until the transaction is committed. If an error occurs before committing the transaction, must revert to its previous state. The third main transaction state is a committed state. In the committed state, all changes made by the transaction are permanently applied. As we know, committed means is permanent. So that in committed state, the transactions are permanently applied. This state guarantees that the transaction's effects are durable and visible to other transactions. Once committed, a transaction cannot be undone. Failed state. A transaction enters the failed state if it encounters an error during execution. It signifies that the transaction cannot proceed to completion. The system must then decide whether to roll back or abort the transaction. In failed state, the transaction enters the failed state, it encounters an error. When error occurs, it enters into the failed state. Aborted state is a last state in a transaction states overview. An aborted state indicates that a transaction has been rolled back due to failure or an explicit abort request. If an failure occurs, so the state indicates as been rolled back due to failure. All changes made by the transaction are undone, restoring the database to its prior state. This ensures that no partial or inconsistent data is left in the database. Introduction to caa-2 properties. caa-2 properties are also known as transaction properties. caa-2 stands for A stands for atomicity and C stands for consistency, I stands for isolation and D stands for durability. These properties are fundamental to ensuring transaction reliability. They work together to maintain the integrity of the database during transaction processing. In this slide, we are saying ACID means A means atomicity and C means consistency, I means isolation and D means durability. Let us discuss about atomicity. Atomicity ensures that a transaction is treated as a single individual unit. If any part of the transaction fails, the entire transaction is rolled back. This guarantees that the database remains unchanged if a transaction cannot be completed successfully. As we all know, in aborted state, the entire transaction is rolled back. The third property is consistency. Consistency guarantees that a transaction will leave the database in a valid state. Each transaction must adhere to predefined rules and constraints. Violations of these rules can lead to data consumption, which consistency aims to prevent. The next property is isolation. Isolation ensures that transactions are executed independently without interference. This property prevents concurrent transactions from affecting each other's outcomes. Isolation is crucial for maintaining data integrity in multi-user database environments. Coming to the last property, durability. Durability guarantees that once a transaction is committed, its changes are permanent. Even in event of a system failure, the committed changes remain intact. This property ensures that users can rely on the database's stability and reliability. Introduction to consistency and recoverability. Database systems prioritize data integrity and consistency to ensure reliable transactions. Consistency is maintained through the use of ACID properties. Recoverability is critical for restoring data after failures, ensuring minimal loss and maintaining the database state. Mechanisms for ensuring consistency. Transaction logs are used to record all changes made during transactions, allowing for rollback if needed. Locking mechanisms prevent multiple transactions from accessing the same data simultaneously, preserving data integrity. Validation checks are implemented to ensure that any data modification adheres to defined rules and constraints. Strategies for recoverability. In this, recoverability means backup. Database backups are regularly scheduled to create restore points in case of data loss or corruption. Redo and undo locks are maintained to facilitate recovery by replaying transactions or reversing changes as necessary. Replica databases can be employed to provide high availability and ensure that a backup available in case of primary database failure. In database backups are scheduled to create restore points in case of data loss or corruptions. There are facilitate recovery by replaying transactions by using redo and undo locks. At last, conclusion. What we can conclude from other topics are transaction states manage the life cycle of each operation, and ACID properties ensure reliability even in failures. Together, they maintain data integrity and recoverability. Thank you for giving me this opportunity. Have a nice day.